Hey class, this video is on similar figures. So just going to get to this beginning part has a lot of definitions. We'll get to 3 examples where we're going to be determining if 2 figures are similar, identifying missing side lengths, and then get to an application that has a real world example. Okay. All right, so this first part kind of already filled out for you. So similarity, it is. So 2 figures are similar if the second can be obtained from the first by a sequence of transformations or dilations. We have this triangle ABC, which is right here. This symbol here is the symbol for similar. It's similar to DEF. So I'm just going to draw, and I want you guys to draw this as well. We're going to put another triangle here. I'm just going to kind of slant it a little bit. I'm going to draw something that looks like this. And keep going. Alright, I'll put a right angle here, and it was DEF, so I'll put DEF, because for this one it went in that order. Alright, so these 2 things can be classified as similar, like not exactly because I just kind of drew it freehand, but the sequence of transformations. So first of all, it was rotated a little bit, and then it was dilated to make it a little bit bigger, so it's an enlargement. So that means that since we can identify those transformations, this is a similar, or these are similar figures to each other. Okay. All right, so let me go and give you the next part. So proportional relationship, and we've dealt with this for scale factor and dilations. So it's a relationship where a relationship between 2 things with a common ratio. So off to the sides of these 2 triangles, let's go and put the side lengths of this bigger one is 6, 8, and 10. And off to the smaller one, it is 3, 4, and 5. So these 2 things have a common ratio in that if I compare the corresponding parts being like this longer side right here for the 8, that corresponds with this 4. This 6 off to the left corresponds with the 3. This 10 corresponds with the 5. It's easy to match up because they're in like the right orientation, but if I were to switch it, you're still able to find out which one corresponds with which side. But if you look at it, they all have a ratio of 2 to 1, meaning everything that was 2 units is now 1 unit. What's really happening there is that our scale factor, I'll put SF, scale factor is 1/2. Right? This triangle is half as big as this pre-image triangle. Okay. And just off to the right, I put this nice little chart here to help you determine the numbers for scale factor. Like what happens with that figure. So if it's between 0 and 1, we have a smaller item than the original. If it's equal to 1, it's the same size as the original, same exact thing. If it's bigger than 1, this is larger. Right? So we have a scale factor of 1/2. So it's getting smaller because that's in between 0 and 1. Okay, next thing is a proportion. This is going to be pretty much how we figure out these problems. So a proportion is an equation with 2 ratios or fractions. It looks like this. We have a fraction equal to another fraction. So I have A over B equal to C over D. Okay. Now I know when we have fractions, it's always tough because we're like, what do we do with it? It's kind of a obstacle in our way of trying to solve an equation. So how do we solve it? We use something we cross multiply. Okay. So cross multiply meaning if we have A over B equal to C over D, I'll write that over here. Use my red pen. I'm just going to draw an arrow going diagonal from B to C and then from A to D. We multiply those 2 things and we set them equal to each other. So I'm just going to squeeze it underneath. It doesn't really matter which order you go. So A times D is AD, add, equal to B times C, which is just BC. All right, so what's nice about this is, we have fractions, we multiply, we don't have any more fractions at that point. But we're going to go over in class of why is that possible, and then really why does it help us. Okay, so we're going to use that idea to help us with this. Example 1 is determine whether triangle ABC is similar to triangle DEF. Now, it is not enough to just say, yeah, they look about the same shape, maybe a different size. No, we're going to prove this with side lengths from these triangles. So we have two examples. It's kind of crowded here, but we're gonna look at example A or example A1. And what you want to do is you want to compare the sides, like which one corresponds with which one. So let's look at this one right here. I'm gonna set up a first fraction here. Let's look at this line segment AB. That length is 8. That corresponds with this one over here, DE. All right. So DE is 12. So what we're going to do is I'm going to put 8 from what we started with. I'm going to put 12 on the denominator. Okay. Now, whenever we ever get to fractions, I know students always, right, you got to be careful with how you set these up, right? Always go from left to right. The left one is going to go on the top of the fraction. The right one is going to go on the bottom. Don't just think like, oh, the bigger one always goes on the bottom or the smaller one always goes on the top. It really depends on the order that you're going. Okay. And then for this, we're going to have this 6 right here for AC. That corresponds with this one, DF. That is 8 units long. So I'm going to put 6 from here over 8. Right, so first, second. Right, we put that on the top and bottom. All right, I'm going to use my black pen here. We're going to cross multiply. And I'm going to I normally start with the top left. So we're going to multiply 8 times 8. Well, 8 times 8 is 64. Always put equal to. Now it's going to be equal to 12 times 6. Now 12 times 6, if you're not sure what it is, just multiply it off to the side. But 12 times 6 is 72. Okay. Now, at this point, there's no simplifying. It's already simplified. We have 64 equal to 72. Since they're not equal to, that means they're not similar. So just going to put no, comma, they are not similar. They look like it, but they do not. Yeah, I'll put a bullet point. But they're not similar to each other. Okay, next one. So let's look at this. We have, again, same triangles labeled ABC and DEF. And we have 2 of the 3 sides that are matched up. Let's go and go to this one right here. I'm going to start out with AB. So AB is 8. So we'll just put a fraction with 8 on top. So which side does that correspond with? Looks like it corresponds with DE just by looking at like the size, and looks like it corresponds to that part. So that is 12. So I'll put 8 over 12. All right, remember, start with that, whichever one we started with. So that is this first one. We're going to go to AC. That is 10 units long. It looks like that corresponds with DF, which is 15 units long. Okay, so it looks like there's some bigger numbers here, so let's just be careful with this. Let's multiply 8 times 15. I'm going to put that off to the side here. 8 times 15. Well, that'll be 40. Carry the 4. 8 times 1 is 8, plus 4 is 12. So this is right here. That is 120. And then multiplying 12 times 10. Well, 12 times 10, where you just add a 0 to the end of the 12, so that's also 120. So since they're equal to each other, that means that, yes, these 2 triangles are similar. All right, there we go. So not too hard there. I think the hardest part is just setting up the fraction. Make sure that you're setting them correctly. If you begin at one triangle for the first fraction, begin at that same triangle on that second fraction. Okay. All right, let's get to the back side. So this is going to be where we have a little bit more math involved. Example 2 is quadrilateral ABCD is similar to quadrilateral WXYZ. So it tells us it's similar. That we're not determining if it is similar. They just are. Okay. But what we're going to do is we're going to set up a proportion to find the missing measures. So what I did, like just terribly, is I drew 2 quadrilaterals. If you notice on each angle, they have like arcs here. It's just, all it means is if they have one arc, they're congruent, they're equal to each other. Right? If it has 2, they're congruent, 3, and then 4 congruent, right, to each other. So that is, in case you're wondering what that is. Now here, we're going to look at, we have 3 of the 4 sides for each quadrilateral. So what we're going to do in these boxes here, just to kind of help set it up, you don't always have to do this, but I think it's important to take our time with this. So let's look at this 13. So that's AD. So I'm just going to put on here, we're going to have 13. So that corresponds to which part over here? It looks like it's WZ. Right, it's in between the 1 and the 4 arc. So 1 and 4, that is 19.5. I'm going to go to BC. Doesn't matter order for this. BC, that is 12. So where does that correspond with? Looks like that's the M right here. So this is 12 over M. And then looks like on the bottom part we have 10 over 15. Okay. So then at this point, to set up a proportion, we can use 2 of these 3 fractions. It doesn't matter, like if we switch them, right? It's still gonna be the same thing. I'm gonna go to using these 2 here. Right? I probably don't want to use this one. It is a decimal, but you know, let's stick away with that decimal. You can still get the same answer with it. But I'm just gonna use it a different way, or just use 2 different ones. So let's use the 12 over M, and then the 10 over 15. All right. Now let's go and cross multiply. So we have M times 10. So M times 10 is M10, or you always put the coefficient in front. So 10M equal to 12 times 15. Always do some scratch work here. Don't just look at it. So 2 times 5 is 10. Carry the 1. This will be 3. Placeholder, and then 1 and 5. Or just make sure you're organized when you multiply with double digits. This is 180. All right. Now this becomes a one-step equation at this point, and this is something that you guys all know how to do. We have 10m equal to 180. You're just going to divide both sides by 10, right? Because it's multiplying, so we're not going to subtract. We're always going to divide to get rid of multiplication. 10 divided by 10 is 1, so in this case, we're just going to have m equal to 180 divided by 10 is just 18. Like zeros cancel out, but it is just m equal to 18. So I'm going to just put where m is, I'm just going to put 18 units. UN. All right, not too hard there. So we have fractions, set them equal to each other, cross multiply and divide. All right, let's get to this. So we have a word example. We have 2 parts here. We're going to draw it to kind of figure it out what we're going to do here, and then we're going to solve it. So looking at this, it says a fire hydrant 2.5 feet high casts a shadow that is a 5-foot shadow. How tall is a street lamp that casts a 26-foot shadow? So, and then it says let H represent the height of the street lamp. So let's go and draw something here. It's probably going to look like a triangle, so let's just get at that. So let's begin with this fire hydrant. I'm going to do the best that I can to draw a fire hydrant. It's going to be terrible, okay? It always is. How do I do this? Okay. I'm going to go like this. Okay. That's not that good, but you guys get the idea. So let's go and put that this is 2.5. And then right over here, it's going to cast a shadow. I'm just going to scribble some stuff, whatever. This is 5 feet. Okay. And then really that's what's happening here. So we have like this triangle that's formed from the fire hydrant and the shadow. I just drew a diagonal line because it's kind of going from the top of the fire hydrant to the bottom of the or top of the shadow, far left. All right, let's get to drawing a street lamp. Let's also do this. So street lamp, we don't know how tall it is, so let's just go and draw a street lamp for the fun of it. Street lamp. That's my street lamp, guys. So this, we don't know how tall it is, so we're just going to put H. And this casts a shadow. Let's go and draw a shadow over here. Okay, you guys get the idea. And I'll draw a dashed line. And this shadow we know is 26 feet long. Okay. So we have 2 triangles. All we need to do is we need to look at the corresponding parts here. So looking at this, let's look at, we're going to compare the fire hydrant to the street lamp. So the fire hydrant is 2.5. And the street lamp, we don't know how tall that is. So we're going to put H. Right, and just like the second example, this is how we're going to set it up. Let's look at the bottom parts here, the shadow part. The shadow for the fire hydrant is 5 feet. That corresponds with the shadow of the street lamp, which is 26 feet. Okay, so let's go into cross multiply. So let's multiply H times 5, which is 5H. Okay, And then we're going to multiply... Ooh, sorry, that's not... It's supposed to be 26. 2.5 times 26, that's going to be kind of hard to do, so let's go ahead and just multiply off to the side. Alright, just time consuming, don't confuse this with being hard. So this will be 30, put 0 here, carry the 3. This will be 10 plus 3, which is 13. Placeholder of 0. 2 times 6 is 12, we'll put a 1, and that becomes 5. Alright, let's add some stuff. This will be 0, 5, and 6. Now, we'll have to take into account our decimal. So decimal is 1 space, so we're going to move it 1 space. So this is, it's 65.0, which is fine, it's just 65. Alright, so now what we do is we divide both sides by 5. Remember, we're finding the height of the street lamp. We're going to have h equal to, now to short divide, 5 can go into 6 once. So I'm going to put, 1 with the remainder of 1. And then it could go into 5 3 times. So this is h equal to 13. You could just long divide if you need to. But we're going to put 13 feet. And there we go. So just like the second example. Alright guys, we're going to practice this quite a bit. Let me know if you guys got questions. Bye.